Okay, I believe we are 1 minute past 4 here, at least at my time zone. So I think we can start this webinar now. For those of you that will be joining us in a few minutes, there will be a recording shared with all of you. So I think we're good to go. Welcome everyone to our second Fusion webinar, Parametric Design Principles and Design Documentation. I am your host, Anna Sotirovska, and without further ado, let's just quickly move on to the agenda for this webinar. So we will start with greetings and introduction as usual, then some webinar highlights, our meeting of our expert trainer, Cengiz, and we'll finish with a little bit about the software and then a bit info on the next webinar. As I mentioned, my name is Anna. I'm partner and engagement executive at KnowledgePoint. I'm your host today. Any questions you might have, you can feel free to send it in the Q&A question box. We'll be reading them on a couple of occasions. As I mentioned, I work at KnowledgePoint. How KnowledgePoint and Autodesk work together. So basically, KnowledgePoint with more than 25 years of excellence in the learning industry is exclusive Autodesk learning partner distributor for the EMEA region. This strategic partnership between KnowledgePoint and Autodesk is a testimonial of our commitment to always provide top-tier educational resources. In terms of today's webinar, so basically you will have the opportunity to explore the parametric design principles. I'm sure you all saw the RC helicopter on the previous page. So our expert trainer will be using RC helicopter and will dive more into the technical drawing on RC helicopter parts. Pretty exciting. Here with us today is Cengiz Kurtoglu. He is the mechanical design engineer, our expert trainer, who will be introducing this part of Fusion. Without any further ado, I will now pass the floor to Cengiz, and we can take it from there.
Thanks a lot, Anna, for the quick intro, and welcome to everyone. I'll start to share my presentation today, which is Anna talked about. I will try to explain parametric design principles in basically Autodesk Fusion and design documentation, which is quite important for the mechanical engineers to manufacture a part directly. And it's called technical drawing in Fusion. I can start with about me. My name is Cengiz. I've been working with Autodesk as a trainer, Autodesk education teams for around 6 years. And I'm a Fusion 360 expert trainer. I received my mechanical engineering degree from the Marmara University in Istanbul. And I also hold my master degree from the INSA Rouen from France. And I'm located in France, Paris. So I've been living in Paris about 2 years, and I'll continue to add some training videos about Fusion 360 on our Design Wagon YouTube channel. So for today, in this webinar, I'll try to explain what is Autodesk Fusion. We also explain in detail in our first webinar, actually. You can check it out directly in the YouTube KnowledgePoint channel. And we will discuss about today design model, design workspace in Fusion, especially in parametric design modeling. We'll try to create a hinge mechanism using parametric modeling, and I'll show you some cool animation which is included RC helicopter in Fusion 360, and we will go into directly to the drawing model in Fusion. After that, I'll try to explain some assembly types on Fusion. Well, it will be a quick intro about Autodesk Fusion, which is quite important because there are lots of different workspaces in Fusion, actually. Well, Autodesk Fusion is a cloud-based software engineering, manufacturing capabilities in this platform. And actually, you can use the electronic circuit design to create mechanical assemblies, generate technical drawings, perform structural analysis, and also you can use for the topology optimization or generative design methods or rendering or animation in Fusion 360. Well, Fusion is a cloud-based collaboration and accessibility directly to Chrome. Well, I'll explain in detail using some projects in my presentation. Well, firstly, we'll start with the design workspace. Well, in the design workspace, which is called computer-aided design, like solid modeling tab, we can create some solid modeling or create form modeling, T-spline modeling, or directly to the mesh modeling, automatically converted to solid models. Additionally, at the same workspace, you can design surfaces or sheet metal, which is fairly common techniques in many industries. After downloading or uploading your mesh designs, you can switch to CAD modeling tabs in workspace of Fusion. Well, there's a quick motion study which we created in our first webinars. After you design your parts, like a robotic arm parts, you can modify a joint tab at the same model. After that, for the joints, which you can see for all axes, 6 axes, you can assign some other details to animate your models. On this projects, which we used for the automation of a robotic arm, we have to detect all axis rotation, all angles. As you can see, there are some joints in there and they are changing. Well, for that, we created a motion study directly on Fusion design workspace, and after we switched to robotic automation parts, and it continue all the projects like this way. Well, today I'll try to explain some other techniques, parametric design in a prosthetic solid modeling, like refers to specific parameters and the ability all the values of these parameters during design process. In prosthetic solid model design, parametric design involves controlling various features of this specific projects. For example, parameters in this design could include factors of length, width, material thickness, or so on. With the parametric design, there's a various of the designs. it will be allowed create different versions of the designs, like designers or engineers, which will be greater flexibility and to speed up your old projects, like changing a single parameter on this type of projects. Well, these tools are very, very game-changing, and this makes the design process more efficient, allow a quick generation of various designs that gather to different requirements. Because today we are using, for example, 3D printers, and 3D printers allows us to manufacture custom parts. In these types of projects, for all humans, they will be necessary custom parts, which is very, very important to create your parts as a parametric design. Well, on the other hand, Fusion have a render workspace. Normally, you can design your parts directly on Fusion, or maybe you already created your parts using other 3D softwares. You can use the render workspace for high quality images or animation on Fusion, which is quite handy, because normally rendering is a little bit longer time necessary to create these images, but using cloud system on Fusion, it's quick renders, high quality images get created using a cloud system. So what is the cloud system? They'll send all parameters to the cloud space, and it's not necessary high quality or high specification on your computer directly, which is quite important. And also I'll show you how to use Fusion on your web browser directly. So on the other hand, there's an animation workspace on Fusion. It's also quite important to create your scene and the visibility of your projects for your jury, or for example for your thesis, or for explain your projects to clients. It's very handy, because I already used the motion study and also animation workspaces. I will explain using RC Helicopter today. Well, for the competitions about the 3D design, it's really handy to create an animation with your parts, with your 3D parts, because the jury or the people wants to visualize your 3D parts. After you get some animation about your mechanism, which is explain your mechanism, it's quite well, and it worked directly, as you can see. Well, I'll suggest to use this animation model in on your Fusion. Well, if you're a member of an engineering discipline, you already know how important to analyze your projects before you start manufacturing. Well, currently, 12 different analysis types available in Fusion. You can analyze static stress in your model, structural loads, stresses, nonlinear static stress, shape optimization. While I definitely prefer to use a static stress before I manufacturing projects. Or shape optimization or topology optimization is widely used study that optimizes parts to make them lightweight and structurally efficient based on your preferred condition. There is some quick animation on our next webinars. We will take into deep look at the simulation tools on Fusion. In addition, we will analyze the static constraints of the part that we are going to design today. Well, the manufacturing parts to create the G-code for your parts that you want to create using some 5-axis milling or 3D printing additive manufacturing parts, you can change the workspaces as designed to manufacture, and then all tools will be changed to create your G-codes using Autodesk Fusion. I can easily say that you may still encounter issues when converting your design parts format to another manufacturing or analysis software. But Fusion has all workspace needed to bring your projects to create as soon as possible, to prototype them. Well, on the other hand, technical drawing tools, which is available on Fusion, we will use today to explain every detail to manufacturers, because well, I need to manufacture a simple part, but I have to explain to the manufacturer easily, which is understandable for everybody, because it's a language. It's a different language. It's not a English, it's not a French or Turkish. It's a technical drawing language, which is quite important for everyone to manufacture the parts in 3D workspace. So there are some terms to use the different section view, for example, first angle or third angle projection. There are some details about the technical drawing, but today I'll try to explain how to use it on Fusion using some parts that we created on our projects. Well, for me as a mechanical engineer, in some of projects on 3D PCB workspace in a team, it was totally connected with the engineering teams. It was fast, reliable, and up-to-date data formats between teams on the projects. Well, you can create schematics, PCB, or you can use the library management, simulation, or mechanical design on the 3D PCB workspace. I will not explain all details, but if you are an electronic designer, you will be love these parts using directly on Fusion. And also generative design, which my favorite workspace. In a short, generative design is a process of design exploration. Designers or engineers enter design parameters, design goals into the generative design software, along with the parameters such as performance, or materials, or manufacturing types, or cost constraints. The software explores all possible permutation of a solution and quickly generating design alternatives. It will be 3, 10s, 100s, whatever you entered as a parameters. It tests and learns from each iteration what works and what doesn't, using AI, artificial intelligence powered algorithms, which is quite important, because nowadays we'll try to create our parts using some old methods, old CAD modeling methods. Well, today still I'm creating my parts using CAD models techniques, but in in some level, in the future, generative design will be enlarged all algorithms, and we will just enter our parameters as we wish as an engineer or designer, and the algorithms AI will respond us to create some parts directly. And generative design is available from 5 or plus 5 years on Fusion, which is quite cool to check it out on Fusion. Well, let's start learn more about modeling techniques in Autodesk Fusion. Well, I'll start with you don't need to install Fusion on your computer directly. It's finished. You can use directly using your web browser. You can type fusion.online.autodesk.com, and that's it. And I'll show you how it's work on my account. Normally, after you enter all information using Autodesk, launch Fusion 360, and it will be available all details of your projects using your web browser, which you want to use in some design workspace, for example. Today, I'll try to explain some parametric models using design workspace. For example, I can create my parts directly on my web browser. It's very, very cool because I don't have access on some projects to access my computer, but I always access a computer and a web browser. After you connect it on your account, now I will not necessarily to download Fusion 360 on my computer. You can use directly on your web browser all details about 3D designing on your web browser. Well, which is quite interesting. Now I will just show you how it works. Just quick example. As you can see, I already created a sketch for this project, and I try to modify this input, which is 600 millimeters. I change for example, 700 millimeters. Well, as you can see, after I modify the value, all other values with respect to this input, it's changed because these inputs, these dimensions are created as a parametric design principles. Well, I can finish my sketch and all parts which change, and you can continue to work on this project. You can save using this web browser. After you can see immediately all the other software that you enter on your Fusion. Well, let's continue on our presentation. Well, as you can see, it's the same projects. Likewise, I'll explain some parameters details. Well, there is a window which is allowed to modify all parameters. As you can see, it's not just sketch, it's also include the features as a extrude 1, extrude 2, a taper angle, fillet, like we can use the modify properties, modify tools as a fillet. Which tools as you wish, as a sketch or extrude, you can enter your parameters quickly. It's very, very simple. For example, like I showed you on the example, there is a value 600 millimeters in the linear dimension, which is, if I change the value for 450 millimeters, it will change all other features, sketches, and the tools like modify tools with respect to input value. This is the first input that I just want to change for these projects. Well, like a scale up or scale down all the parameters that I want to change. Well, D1 is a name for the first point, the input, the unique input. After I entered some values as D1 multiply 0.5, for example. And Fusion compute all the values and created directly new parameters with respect to these input. Well, I can show you a quick animation. As you can see, I changed the value for explanation. You will see all values with respect to D1. It's not necessary to all values with respect to one input. It's just an example. But to scale up with using one parameters, you have to enter all values with respect to this one input. Well, I would like to switch Fusion, and I want to create a new model using parametric design principles. Well, to create a new projects, I would suggest to use these create sketch parts. And as you can see, there are some planes. Generally, I prefer to use the plane XY. In the view cube, I can see the X axis, Y axis, and a Z axis. So the XY plane, which is there. Now, I just want to create a rectangle. For that, normally, if you type R on your keyboard for a quick way, the Fusion enter the rectangle tools directly. So you can change types of the rectangle. I just want to use the center rectangle. Normally, I have a shortcut for center rectangle. If you want to add some shortcuts, you can use this quick tip. Rectangle and center rectangle, there's 3 points. If you click the 3 points, you can change the keyboard shortcut. To get some speed up on your projects. For example, I generally use Shift R to open, to access to my center rectangle. Now I type the Shift R on my keyboard, and it will be open directly center rectangle. Now I click the origin points, and I'm creating a rectangle directly with no dimension. After that, I'll type to D to add some dimension, maybe 200 millimeter. And then I'll add other dimension, but with respect to first one. Well, I don't know the name of the first input. I can quickly get knowledge about this one in your mouse about the 200. On the 200, with clicking or without clicking, I can see D1. It's the name of the first dimension, D1, divided by 2, for example, and then Fusion computed directly the first input divided by 2, or you can change 2.2, for example. It's about your project. It's about your details about the on your projects. As you can see, when I change the first value about 250, it will change automatically. So I'm continuing to change my rectangle. I'll add a circle using C key on my keyboard. I'll enter 80 millimeter center rectangle. It's nice. And I just want to create two slots on this design. Well, I have to create some constructed lines, which is important to me, because I just need to define the all dimensions for my new center-to-center slot. Well, so I can add a line which is constant here and here. As you can see, when I click to here, there is an icon. Fusion told me about this line, which will be horizontal. Okay, very nice. And then this line should be as a line type, as a construction line. You can use the X key or construction line type. Well, after that, I can change the dimension for that, which is important to me to create a slot here. Well, I will enter as a dimension, which is exactly same value as a diameter of this circle. Okay, so if I change the value as a 100 millimeter, the value will be changed. Well, there is two different parameter input as a length of the rectangle and diameter of the circle. It's okay. Now, I just want to use the mirror tool. Well, why is that? Because I want to create a symmetrical line here, which is exactly the same value. But I don't want to add some other dimension. So I can use the mirror tool. For use the mirror tool, you can add line to use for to say to Fusion, this is the line for mirror line. It's not important. It will be just here. I just want to use construction line also. So now in the create toolbox, there's some different types of tools as a polygon, rectangle, ellipse, slot. But after this section, there are some other tools like mirror. In the sketch plane, sketch interface, you can use the mirror tool using sketch objects. Well, first sketch objects, this line that I want to create to other side of the mirror line, and Fusion asks me the mirror line, and I'm choosing this select, and quickly I select this line, and Fusion used this line as a mirror line, and it creates new line on the other side of the mirror line. Well, I don't want to create lots of parameters, lots of inputs on my parametric design, which is quite important because it's not a big projects for me, for you, for all of us. It's a basic principles. But after you created some complicated parts, complicated designs, we want to simplicity to access all details on our projects. So you can run away to create lots of parametric inputs. So now I can add center to center slot in here, because I have a 2 points, 1 point in there and the other point in there. So I can create some slot directly to here. Well, very nice. I have to add, normally we already define our length of the slot. It's okay, it's done. But it should be add a value for the diameter. So I'll type the D key to get to assign a dimension. In there, it's add some value using this center, this circle as an input, and divided by 4 or 5. It's not important. You can add you can change whenever you want. Well, as you can see, it's all sketch objects are black. It says me it's fully constrained, which is great for creating a sketch object. Now I just want to make same things to add other slot to other side of this mirror line. So normally I'll go to the create and I'll choose the mirror. It's long. You can type S key as a search, S key on your Fusion. After you search toolbox skin shortcuts, you can add you can type mirror, or there is a icon you can access on your tools that you use in general. I generally use this S key for a quick shortcuts. In general, if you are a designer or engineers, which you are using some softwares on computer-aided design, after you create some projects, you just need to speed on your creating time. So you can use some tips about like this one, this search toolbox. Well, I'm selecting mirror, or I type. If you want to add to this window, you can add directly to there. Mirror, well, objects. Well, which objects that I want to add on the other side of the mirror line, it just slots all the objects on the slots. Mirror line is the same mirror line in here. That's okay. That's great. So you don't need to create new slots to create these parts, or you don't need to add some new parametric inputs. It's very, very important. So I'll continue to create these parts. So for me, it's okay. I'll enter to E key to extrude up for these projects. Now, well, it's quite important to remember the name of the input, because there's a D1 for a 200 millimeters, there's a D2, D3 as a 80 millimeter. So, well, if I type D1, it'll add 250 millimeter as a extrude distance. Now I'll add some, for example, 6 divided by 6, about 41. It's okay. And as you can see, I assign a parametric modeling tool as a extrude parts. So you can continue to add some details on your projects, while, for example, fillet. It's very, very handy to manufacture your parts, to get some organic shapes. It's important to add some details as a chamfer or fillets. I'll choose 4 edges of these parts. Now I'm adding new value for these fillets. Normally, the projects has a some configuration. For example, one party for 100 parts, which will be manufactured as the value of 250 millimeter, and the other parts, other 50 parts, which should be manufactured as a 200 millimeter. So the fillet parts, the fillets, if you want to add the new parameters to assign a parametric principles, it's okay. But I just want to create a short input to change the fillet values. And normally I can add 40 millimeter for this new fillet value, radius value. Okay, I'll add the fillet values. Well, now I need to these values to change directly using parameters tools. Well, in the modify section, there is a change parameters dialog in there. So I'll open a sketch. As you can see, there are all details you can change using these parameters here. There's a dimension to D1 250 millimeters, dimension to 80 millimeter, and radius 40 millimeter. And the name of the these values, it's D9. So I can continue to assign using this name of the radius parts, where, well, D9 for fillet. So I'll push the F button to open the fillet. Well, I just want to add some fillet in this section. These two edges. Normally, D9 is a 40 millimeter. So if I add D9 divided by 8, for example, as you can see, I can add torque input on my parts, which is use the fillet respective fillet input. So it's all done, and now I don't need to open the all sketch parts to change, to modify the all dimension. It's not necessary. I can quickly enter my value directly here. For example, 30 millimeter, it'll change the length of the as a 30 millimeter, and these circle, for example, 80 millimeter, the second input, I can change 100 millimeter, enter, which is okay. And I can change the fillet values, or I just need to change the dimension of 100. You can always access to change, modify, or you can modify all values directly using here also. It's quite interesting. For example, normally I added as a 100 millimeter or D1 divided by 2. It's about your projects, and well, it's quite interesting, and you can use on your projects, especially on your research projects, which is allow us to create other simulation entries. For example, I have to add some analyze parameters for these parts, and I have to change the modify the design, and you can continue on your parts to analyze on your new design projects. Well, I hope it's okay for you to understand all the details. I just want to ask Anna if there is any question about the on this part, if there is anything.
Yeah, Cengiz, at this moment we don't have any questions in the Q&A box, but everyone do feel free to just type your question, and we'll be Cengiz actually will answer it.
Yes, if you have any question, you can ask about the Fusion in general, or about the project, about parametric modeling. I'll happy to answer in this webinar directly here. And now I want to continue on the next slide about the joints. Normally, we already used motion study on our first webinars, but I want a quick reminder using these parts. What is motion study, and what's the importance of the joints? Well, there's a question about the material parametrics of materials. Well, you can change all the parameters as a custom materials. You can assign a custom materials on your properties. For example, you already use the stainless steel, but you just want to change the Young modulus as a custom parametric of your material. Now you can create a custom materials on your fusion analysis. Well, we will deep dive on our next webinars about the simulation analysis, which is quite important also. Thanks for the question. So I'm getting into Fusion. You're welcome. Well, quick intro about the joints. If you want to create joints your parts to create an assembly on your parts, as you can see, it's an assemble of your parts. You have to change bodies as a components. It's all parts. It's all components that contain some bodies on the on individual of the all components. After you modify your parts as a components, you can ready to assemble of your parts. Well, as you can see, there's a revolve joints in there, revolve joints for these two parts, and slider mechanism, slider parts, slider joints in there for these two cylinders. And also there's another revolve to complete our assemblies. Well, there's no limits for these parts. Normally, you can assign a limits of your parts. As you can see, the two parts, it's not quite responding the physical way of our project, but you can assign a added value for the joints. There's a joints parts, joint fissure. I don't know the English name of the I hope I'll remember. Slider 9, there's an added motion limits. Well, in this parts, the minimum and maximum, for example, for the minus 60 millimeter, and the other parts 0, which is quite well. After assign the limits of your parts, this is the limits. This is the final point for your this mechanism. So, which is important to get knowledge about your parts, to get knowledge about your strict the limits of your joints. So, in this parts, you can animate your assembles using animate joints relationships, which is allowed to animate all your models using these parts. Also, as we created a project in our first webinars on YouTube knowledge point channel. You can check it out. You can assemble motion study for these parts. Well, on the first projects on the robotic arms, there are several different revolves that we have to add joints. But for these projects, it's not necessary to add other joints. It's just one joint as a slider joint, as a step 100 and distance 0. It's okay. Enter. As you can see, I enter as a value on the end of the step, end of the motion. It should be the position 0 value, and the first frame, it should be a minus 600. Well, which is quite important to assign a motion study on your projects, because the mechanism, all mechanism should be should be told us the motion on the software. After that, we have to pass manufacturing details, but it should be all the details of the motion on this software. We could get access to movement of the parts. You can change the speed, whatever you want, and you can change the mode as a keep and go, and that's okay. If it says it's okay, it's done, you can access to a motion study as a motion study 1. After that, you can use on your render workspace to get animation on your render workspace directly. Well, now I would like to continue other explanation as a hinge mechanism design. I will quickly show you to create 2 parts and how do we get add some joints on these parts. Well, let's go back to Fusion. I will change. I will create a new design, and I just want to quickly create a part using create sketch. Normally, I'll choose the XY axis. Now I can create a rectangle for these parts. Normally you can continue using these parts, but I just want to explain other approach to create your designs. Well, there's a in the create section, there's a box in there. So I'll same as sketch, I have to choose a plane as a XY plane. For example, I'll try to get origin, snap points of origin, and I'm selecting these parts. As you can see, it's a rectangle. It's a quick rectangle, and it'll add some extrude to create your parts. So the dimension is not important. I just want to quick explanation about the mechanism. So I want to create a new box on the other side, but I have to modify these parts. So you can continue to use box to cut these parts, or now I just want to add new sketch on these parts. If you select this face, for example, I need to create a rectangle on these parts. I quickly enter R key and then I'm selecting center rectangle, or Shift R in my case. I'm searching the midpoint of these parts. Normally, it's not origin. It's the midpoint of these parts. The snap tool, it's catch the midpoint as a triangle, as an icon of the triangle. It's here. So I'm creating a rectangle like this way. The dimension is not important. I just want to explain a quick explanation about the mechanism. So now we already use the extrude tool as a join, as a create the parts, but now I want to use the operation as a cut operation. So now I get in the cut. So I want to add other side of the parts for this mechanism. I can quickly create a sketch for these parts. I want to show you other parameters, other details that you can use on Fusion. Well, normally you can always use the line as a tool to catch up these parts, but it's it should be a projected view in there. Well, in the projected view, project include, when I push the these parts, as you can see, the lines, it comes, and I can quickly add some rectangle for these parts. Well, the hinge mechanism, it will start to for these parts. Well, I'll selecting E key to create the new extrudes for these parts, but it should be as an operation, it's not joined. It should be a new body or new component, because it should be two bodies to create a new mechanism for these parts. Well, normally, after I selecting V as a visual, you can select Q key, press pull for these faces, because I just want to change the parts, because it's like this one, 2 millimeter or 1 millimeter. It's not it's important on your project, but I just want to quick explanation for these parts. Okay, hit the OK button, and now I have to add some cylinder here. You can use the cylinder, solid cylinder, directly to here to cut the parts, but also you can create a sketch to add some details on your parametric models for your projects. Well, I'm adding a quick cylinder to other side of the project, and the operation will be automatically cut, which is great. Now, after you selecting, right click on your mouse, repeat cylinder for these parts, and it'll catch the center of the cylinder that we created for these projects. Now I'm adding some pin for these parts, hit the OK button. So it's a very, very quick explanation about the hinge. Normally there are two different bodies. I just want to create a components from these parts, body 2, create components from bodies, and now I can change, I can move these parts. So if you hit the as an assemble joint or as built joint, you can start to create, you can start to assign, add some movement for your projects. Well, as a part, this new component should be revolved using these axes. As you can see, it starts to get the hinge mechanism in there. Well, the all parts needs to be modified, because as you can see, the mechanism, it's not quite well, but the logic of the creation, a quick creation of your assembles, this is the way to get knowledge about the component. But if you change this component, this body as a component, you have to, you don't have a quick access on your bodies. You have to add ground plane for ground as these parts, and after that you can adjust your projects. Well, for this part, for example, it should be ground. After add your ground, it doesn't move, and it will continue to move these parts. Well, I want to continue as an explanation of a planetary gear, and we will dive into the RC helicopter projects quickly. Well, as a planetary gear is a gear system commonly used in mechanical engineering. We already explained on our first webinar. I just want to add some videos about that we created using a 3D printer, these planetary gear, using fused deposition modeling, FDM styles. It's important to use the material selections on your 3D printer as a ABS, PETG, or other parts. And it's important to resolution and layer height to get the knowledge about the tolerances or clearance or infill percentage or print orientation, which is quite important. And also the post-processing on your parts that you created. So I just want to explain the other parts that we can access on our design parameters. Normally, after design a projects, you can pass the animation model. Well, in the animation model on Fusion, as you can see, all tools are changed. Normally, we create some parts using extrude, solid modeling workspaces, or assembles. But now we change the workspace as an animation. And after that, we only see the animation tools as a storyboard, transform, annotation, weave. Well, this is the interface that I like to, because it's very, very simple. It's very handy to use on your projects, because I need to tool that I want to use. I don't need to see, I don't need to enter some other tools which is available on the software, but I don't want to use an extrude tool on my animation projects. So the logic of the workspaces, which is quite handy. Now, as you can see on the RC helicopter projects, you can change the all rotation as a 700 RPM, or what you are exploring on your projects. You can assign your details for the projects. In that project, I just want to rotate the parts as quickly as I can. For the components, which is blade holder at the same time, but in the details, sorry, I'm coming back. Well, no, not this one. Sorry for the, well. So, yeah, I modify all parts, and then I add some camera motion view. It's quite important to add some details, to add some movement on your projects. In this case, the helicopter should be fly to on my animation. So I added a camera animation, view animation for the project. Normally, the helicopter in the old animation, it stands at the same position, but the camera is moving. So the animation was created using camera animation. After that, you can export whatever format you want. So I just want to add some details on our next webinars. We will create these parts. If you're interested on our next webinars about the simulation, we will create a static stress simulation using these parts. So now I will use the drawing details, technical drawing details for these parts. But if you're interested to create the parts, I will show you all details about the these parts. You can design your parts, and on our next webinars, you can follow me at the same times on your Fusion to create a simulation analysis. To explain the technical drawings, as an animation model, drawing model is a different workspace on Fusion. You can add, you can assign or all dimensions for your parts to explain the manufacturers. You can add details for your views, for your dimensions, for your material selection. For these parts, to project it, to create a projected view, you can use the projected view as to create front view, right view, or top view, or you can add some modify to add some details for your models, or which is quite important for the holes that that need to be at center line, center mark, or center mark pattern. For the dimensions, I generally use the D key, but some way you have to need some specific angular dimension. You can add some text to notation to get knowledge about the notation, and it's a revision number, or first angle or third angle, or the surface texture for the finishing your manufacturing parts, or insert image, or the table. Well, if you have experience about the technical drawing, it's not a big deal to create projects on Fusion, because it's very simple. It's very handy to create your parts as a technical drawing. It's quite fast to create projects on your technical drawing parts. After you finished your projects, you can export as PDF, DVG on AutoCAD, for example. It's very handful to use your projects on AutoCAD or vice versa. And at the same time, you can search your drawings on your web browser, because in general, you don't need to choose your parts as a project on the technical drawings. So you have access to your technical drawing on this side of the to use your parts. Well, I'll show you the dimension of these parts. If you have time, you can create your own parts using Fusion. And after, we will switch to simulation workspace to create these static stress analysis. And we will raise these parts to compare two different simulation or two different materials to compare the results. Well, you can get some screenshots on these parts, technical drawing. Well, it's not a millimeter, it's an inch. If you want to change as an inch for your parts, normally I'm using millimeters to create the parts, but before I started, in the document settings, there's a units millimeter. I'm selecting millimeter as an inch, and now, for example, quick intro for the parts, I'm selecting D. It's a 4-inch. In this parts, for example, 7 plus 5 divided 7 plus 5 divided by 8. 7 plus 5 divided by 8. Yeah, it will be 7.625. It's inch, and you can continue to create your parts after you created. Maybe we can on our next webinar we will use the same parts to create our static simulation analysis. Well, I just want to explain quick intro about the technical drawing. After design workspace, I finished the design workspace. I want to change my workspace as a drawing. For that, Fusion asks me some details about the standards. In general, I'm using ISO, but you can use the ASME, millimeter as a unit, sheet size, or A4 or A3, whatever you want. You can also modify on the technical drawing, but it's the first inputs that Fusion wants me to get information about the technical drawing. As you can see, the interface is changed. So I don't need to add some details, add some solid modeling tabs or assembles, just the technical drawings. So for the first part, I'm using A3. You can change the scale, for example, 1 to 5. Place the base view. I'm choosing the base view, and the style visible and the hidden edges. It's important for our next steps. I'm selecting OK for the first view, and to create the top view or front view, you can use the projected view. There is a shortcut P on your keyboard. For the parent view, after I push the P button, it's the top view, and the right view, and I'm adding a isometric view for my project. I just want to change the isometric view as a shaded. It's not necessary to add some dimension details for that, and it's very handy. As you used on your design workspace, you can quickly typing D key to add your details. 300 millimeters, for example, for these parts, 75, for these parts, as you can see, you can change the dimensions. You can add the dimensions on the technical drawing. After that, you can continue to add some details. For example, we should add center line for these holes. First edge, second edge. As you can see, it's very quick way to create the to add some center lines, and you can add some text to explain the technical drawings, and you can modify the title to add some details. You can add the scale. It's very handy to get knowledge about the parts for the manufacturer. As you can see, it's a parametric design. For the scale value, I have to add you can add your technical reference, for example, part 001. And also, I just want to add some notes for my manufacturer. For example, scale. Scale 1 to 5. For the materials, for example, you can add stainless steel 316. You can add your details, and if it's revision, you can add some details. And for that, you can use the AutoCAD if you are already using for your projects to switch the technical drawing parts as a DVG format, or for a laser cutting. I already used as a parts to use the laser cutting parameters. These lines, you can use the DVG file or export PDF directly. So if there is any question about these subjects, I just want to answer the question. Anna, if there is any question.
Not at the moment.
Okay. Well, in general, in Fusion 360, I just want to add some very important information about the technical drawing. Normally, it's a first angle or third angle information for your technical drawings. You can change using it's a little icon for your photos and the preferences. There's a lots of information and preferences for Fusion that want to change. Well, for the French speakers, Spanish speakers, Turkish, Chinese, you can change your user language using these preferences on Fusion also. And on our case, for the technical drawing details, there's a drawing tool, drawing template. You can change the default values as an ISO, millimeter, A3, and also projection angle, which is quite important because third angle or first angle, two different things for the technical drawings. You can change, you can modify using this project angle, third angle. After you apply this value, okay, you can create a new design, new technical design, because this design, it's already created as a third angle. I cannot change, but after you change, after you assign this value as a projection angle, you can create a new design and you can continue to create your parts. Also, there is details about the text height group to change your values, to change your font, modify the old values. I would like to let you to create your projects, and if you have a question, you can send me a mail, or on our next webinars, I will happy to answer your questions. Well. On our next webinars, I will try to explain the mechanical assemble strategies and product design with Fusion 360 using table-wise assembles. We will explain in details some other parts, assemble mechanism, and I will try to explain a render workspace. And thanks a lot for participating. If you have any question, I will be happy to answer.
Thank you, Cengiz.
Yes, you're welcome.
If you have any questions, you can pop now in the Q&A section. I will take over the screen now.
Sure, thanks a lot.
Okay, so thank you, Cengiz. It was very interesting, very interesting parts you've covered. I want to finish this webinar by reminding you as we also the power of Fusion, and Fusion being an integral tool for students and educators. It is basically a bridge between the technical knowledge you have and the practical application. Anyone who is not using Fusion but is interested, you can go to the autodesk.com education, this link, and you can enter a wealth of materials and resources that you can leverage in Fusion, and also, as you can see, other softwares as well. Cengiz already covered this, so we have our next webinar, Mechanical Assembly Strategies and Product Design, which is scheduled for December 20th, same time. So hopefully see you then. And also as a reminder, after this webinar, we'll be sending a recording of this webinar, so you can access it if you want. If you have any questions or you want to share any feedback about this webinar, please feel free to send it to my email, anna.zatirovska@knowledgepoint.com. That is all from our side. Have a great day and thank you for attending this webinar.
Thanks a lot, everyone, and see you on the next webinar, I hope.
Bye.
Bye.